Hello everyone, welcome back to the ESP32 lecture series. Today we will cover RTC GPIO and deep sleep. This video is purely an introduction and overview. We are not going to write any code today. The detailed hands-on lecture will come at the appropriate time in the series, so stay tuned for that. What we are going to do today is build the foundation. We will understand why certain GPIOs on the ESP32 stay alive and functional even when the entire chip is essentially shut down. Which are those pins and what wake-up methods are available to us? You will also notice we mention the ULP, the ultra low power coprocessor in this video. The ULP is a powerful topic on its own and it will get its own dedicated portion later in the series. For now, just know it exists and that it lives inside the RTC domain. Let us get into it. RTC GPIO unlock battery powered IoT. Before we dive into the technical stuff, I want to spend just a minute on why this matters, because I think it will completely change how you look at the ESP32. Look at the three columns on this slide. The first column is real-world projects. A weather station that sleeps for 10 minutes, wakes up, reads a sensor, sends the data and goes back to sleep. A smart doorbell that sits in deep sleep but wakes up the instant someone presses the button, thanks to an RTC GPIO wake-up. An asset tracker that pings its location every hour, all running on a single ESL. Now look at the middle column, the power math. If you run an ESP32 in always on mode at around 240 mA, a standard 1200 mAh battery gives you roughly 5 hours. That is not even a full day. But with deep sleep, where the average draw drops to around 120 microamps, with intermittent Wi-Fi working, that same battery lasts 14 months. And the third column is your roadmap for this video. By the end, you will know which 18 GPIOs survive deep sleep, how EXT0 and EXT1 wake-up works, how to use timers and touch as wake-up sources, how to persist data through RTC SRAM, and how to hold a GPIO state during sleep. Master this and you are no longer limited to wall-powered projects. The real world runs on batteries. Let us learn how to design for it. Most GPIOs go dark in deep sleep. So, here is the core problem we need to solve. On the left side of this slide, you can see ESP32 in normal mode. Both CPU cores are running at 240 MHz. All GPIOs are fully functional. Wi-Fi and Bluetooth are active and all peripherals are powered. The current ROM is somewhere between 160 and 240 milliamps. Now look at the right side. This is deep sleep mode. The CPU cores are completely off, GPIO states are not maintained, Wi-Fi and Bluetooth are off, most peripherals are off, and the current drawn drops to around 10 microamps. That is a tiny fraction of what it was before. So, deep sleep is very power efficient, but it creates an obvious problem. If all the GPIOs go dark, how do you wake the thing back up? That is exactly the question we need to answer. And the answer is you need GPIOs that survive deep sleep. Not all of them do, but some of them do. And those are the ones we care about today. Meet the RTC domain. So what is actually happening inside the ESP32 during deep sleep? This slide explains it. Think of the ESP32 as having two zones. The main system, that is everything on the left, shuts down completely during the deep sleep. The CPU cores, Wi-Fi, Bluetooth, most of the GPIO matrix, SPI, I2C, UART, all of it goes off. But then there is a second zone, the RTC domain, on the right side. And this zone, it never truly shuts down. The RTC domain is like a tiny always on portion inside the ESP32. It stays alive no matter what. What lives in the RTC domain? 5 things. First, the RTC collector. This is the brain that manages the sleep and wake cycle. It decides when to wake up and what triggered the wake. Second, the ULP coprocessor. This is a tiny ultra-low power microcontroller that can run its own tiny program while the main CPU sleeps. We will do dedicated videos on the ULP later in this course. It is incredibly powerful. Third, RTC SRAM. 8 kilobytes of memory that survives deep sleep. Anything you store here will still be there when the chip wakes up. Very small but important as it survives the deep sleep. Fourth, RTC GPIOs. 18 specific pins that remain functional during sleep. These are the ones we are here to talk about. And fifth, the touch sensor collector, which can even use a capacitive touch on one of those RTC pins to wake the chip. So the key takeaway from this slide is the RTC domain is always on, design around the RTC domain, and you can build incredible low power systems. RTC GPIOs and wake up sources. This slide shows you exactly which GPIO pins belong to the RTC domain. There are 18 of them: GPIO 0, 2, 3rd, 12 through 15, 25 through 27 and 32 through 39. But pay close attention to the color coding here. The ones marked as input plus output plus wake up. Those are the fully capable RTC GPIOs. You can read from them, write to them and use them as wake up sources. The ones marked as input only, those are the GPIO 34 through 39. These are input only pins. They have no internal pull up or pull down registers and they cannot trigger EXT0 or EXT1 wake up. Keep this in mind. Now you can see the wake up trigger methods. There are 5 of them. EXT0. This wakes the ESP32 based on the logic level of the single pin. You specify which GPIO and what level, high or low, triggers the wake up. EXT1. This monitors multiple pins simultaneously. You can configure it to wake on any pin going high or all pins going low. Timer. You can set a duration in microseconds and the chip wakes up after that time has elapsed. Perfect for periodic sensor readings. A capacitive touch on any one of the touch-capable RTC GPIO pin can trigger a wake up. The ultra-low power coprocessor can run its own tiny program while the main CPU sleeps and then triggers a wake up when it decides the time is right. So you have a lot of flexibility here. The trick is choosing the right wake up source for your application. Now, to summarize, the RTC domain is always on, 18 GPIOs belong to it and you have 5 wake up methods to choose from. If you found this useful, please give it a like. It genuinely helps the channel grow. Drop a comment if you have any question. Next up in the series, we are going to look at ESP32 GPIOs, output, pull-ups and more. So make sure you are subscribed so you do not miss it. See you in the next lecture. Thank you.